Hello and welcome to part 4 of the syringe engine build. My little motor was going to be battery powered and I needed a way of securing the battery holder. The junk drawer had a couple of stainless steel case screws that I'd saved from another piece of scrap equipment. There's a nice bit of M5 thread on one end that I was going to keep. I cut them down and tidied up the rough end. I wanted to cut a nice semicircular groove in the top of the screws, but I didn't have the right tool. I spent a while trying to grind something up, but I could only make it the right size and egg-shaped, or round and the wrong size. I gave up and tried something else. I took a scrap of 3mm silver steel and hardened it. I figured I could get away without tempering, as it would only have to survive a couple of light cuts. I ground a tiny bit of relief on the end to give it some bite, and then drilled the shank of a broken lathe tool and glued the cutter in place. I didn't bother with a retaining screw or a clamp, as it was only really a test. As it turned out, it worked pretty well. My background is in electronics and making a small speed controller wouldn't cause me any problems, but in the end I decided to buy one instead. If I made it, it would have cost 3 times as much and been 3 times as big. Plus, with the winter temperatures in my unheated garage close to freezing, I wanted to get the thing finished. This little Chinese pulse width modulation circuit is little more than a 555 and a MOSFET, but it does everything that I need. The final component to make was a base to fasten everything to. This piece of black acetal plate was rescued from a scrap test jig. It was full of ugly holes, but I had a plan for that. I cut it roughly to size, and then turned one of the square offcuts into a rod. I cut the rod into short dowels, opened out the holes I didn't need and plugged them. Next, I prepared the last ClickSpring superglue arbor of the project. This time it was for milling rather than turning. By doing it this way, I had access to 5 sides of the base without changing the grip. Once the glue had dried, I tidied up the edges. Next, the top surface was cleaned up with a fly cutter. It took a few passes to get the feed and the depth right to leave a decent finish. After that, the edges were finished with a corner rounding cutter. Then I drilled holes to accept all the components. My next problem was getting the plastic off the arbor. It would not budge. I didn't want to risk heating it, so I blocked up one end with blue tack and ran acetone into the other. After about half an hour's soaking, the glue had softened enough to separate the two parts. I tapped the holes ready for assembly. And that was it. To use the engine, some rubber tube is attached to the syringe which connects to a T-piece. One end becomes the output, a pressure gauge in this case, and the other end is connected to a second syringe. The static pressure is simply set with the second syringe and then clamped off. The rate of the oscillating pressure is set by the speed control, and the magnitude is adjustable with the intermediate arm. I don't think the motor I've chosen is ideally suited to this task. I reckon the gearbox shaft isn't supported at both ends and it doesn't like the change in load direction as it's running. Still, it was free and it's good enough for the job. All told, I reckon 90% of the finished item came from recycled materials. The fasteners, batteries and speed control were all new, but everything else came from the junk drawer. So that's it. Thanks for watching.